Hi. Today we're going to look at the Nix source code. On Friday, I looked at the Geeks source code. Geeks is built on top of Nix. At least they use some of the C++ Nix source files in Geeks. And they are related in the sense that they both are functional package managers for Unixy Linux environments that are trying to do things using functional programming languages as a way of configuring the package dependencies. I don't have a ton of time right now, so this will probably be on the shorter side. Mainly, I want to get a sense of where the Nix storage code is and get a feel for what it does and what are the conventions that the developers use, and sort of all of those sorts of things that you can kind of get a feel for doing a fairly quick drive-by. So I'm going to start in the source directory. I have their GitHub open. Okay, so in source, I see a bunch of stuff that looks very relevant, like Nix channel, Nix build, and Nix store, and Nix is where I will start. Let's actually reverse the order of these last two. And in Nix, we have things that look like commands, like copy, daemon, bundle, build, develop, eval, format. And we have nar, which is, last time we saw that nar should be Nix archive. So let's take a look at, so I'm guessing MD is markdown, right? So is this going to be kind of like a README? So it's a little tiny markdown file. Okay, so we'll look at nar.cc, and then I don't see the header files. They may be in a separate includes directory. Let's also take a look at eval and build. I don't know what realization is. Realization just has a single file that's info.md. Okay, and then what else do we got? Nix/source. I think we looked at that already. Nix channel just has a few files, like nixchannel.cc. Similarly, Nix build just has a single nixbuild.cc file. So that makes our life, it makes our choices pretty easy for what to look at in that directory. And then Nix store, we've got a few things. We've got .graph, graphml, and nixstore.cc. .graph might be graph visualization. GraphML, I feel like I've heard of, but I'm not sure what it is. Print.graph is what the header file says. Let's take a look at graphml.cc. XML quote, symbolic name, make edge. We're going to return format edge source. So we're building XML stuff. Is .graph a tool? Yeah, I think it's related to GraphViz. That sounds somewhat familiar. Is it a file format? .graph is a proving format that uses JavaScript implementation of GraphViz to automatically lay out a twine story as a layered graph. I don't know what all that is, but I'm going to assume that .graph is related to GraphViz. Okay, so we're building some XML in this file. Graphml.cc, is that what we just looked at? Make node? Yeah, okay. And then we have nixstore.cc. We're going to include a bunch of stuff from Nix, including archive derivations, .graph globals, build results, storecast, etc. Some stream stuff. We've got this typedef operation, void operation, string op flags and stream op args. Okay, so this seems like a pretty generic operation type. Right. So what is ref? Does this mean reference counted? Is this a C++ feature? Ref. C++ supports user-defined ref classes and ref structs. So where is it in the code? Ref class public sealed. Yeah, I'm not sure. Okay, and so what is it? These data structures are the primary containers by which C++ supports the Windows runtime type system. I don't know if this is related to Windows, though. Windows standard ref. Necessary. So here's an example where it's necessary. So where is it called? Standard ref of data. Wrap the arguments that really need to be references in standard ref. Okay. I'm not sure this is the same as standard ref, but we can take a look and double check. But okay, so standard ref. Are you going to tell me what it is? All right, they're helper functions that generate an object of type standard reference wrapper. And standard reference wrapper is a class template that wraps a reference in a copyable, assignable object. It is frequently used as a mechanism to store references inside standard containers like standard vector, which cannot normally hold references. All right, so are we like using this standard namespace? I'm not sure. So let's assume that this is somehow related to standard ref. We're going to ensure local store, dynamic pointer cast local store of store. And if you don't get your store 2 back, then they're going to throw an error that says you don't have sufficient rights to use this command. Is that the only error that can happen when you do a dynamic pointer cast to local store of store? I don't know. It seems like maybe we should check to see if it's actually an error, a rights issue, permissions issue. And what is store? So let's see. A store is a standard shared pointer to the type store. Okay. And we've got store. We're importing storecast, GC store, log store, and local store. Okay. Use deriver. So we're going to check if something is a derivation path, a store path. And if so, we're just going to return the path unmodified. A lot of use of auto. It'd be nice to know what the type of query path info is. Store query path info of path is going to become an auto info. And if not info deriver, we're going to throw an error and say the deriver of path is not known. Is that the only error that query path info can return? I don't know. I think I'd have to dig in further to find that out. Okay, so we can realize the given path. For derivation, that means build it. For other paths, that means ensure their validity. So realize path, we're going to pass in a store path with outputs and a Boolean flag whether to build or not. We're going to cast to local FS file system store. I'm guessing is FS. And if it's a derivation, we'll do some stuff. What if it's not a derivation? Else, we're going to check if we need to build, and if so, we're going to ensure the path.path. If we don't need to build, and it's not a valid path, we'll have an arrow. And otherwise, we'll do some garbage collection stuff. Add perm root. Okay, so print store path. So realize path. So this is going to realize the given path. For derivation, that means build it. For other paths, it means ensure their validity. Yeah, that's kind of a lot going on in a single function. But okay. Cool. All right, realize the given paths. We've got op realize. It's going to get some op flags and op args. And it's a static void op realize, but it's not one of these ops, is it? We had operation, which took op flags and op args. Okay. Op add fixed, preload the output of a fixed output derivation into the Nix store, add files to the Nix store and print the resulting paths. So how do we add files? So we're going to check if flags are empty, and we're going to throw an unknown flag error if they are. Otherwise, we're going to get, we're going to iterate over the op args, and we're going to call format, standard format, store.print store path, store.add to store, standard string base name of I and I. Add files to the Nix store. But where is it putting these? And why is it printing them to standard out? So I guess the real work is being done here. And they're printing it to standard out as a way of, they're combining the log statement and the actual side effect, perhaps. Op add fixed, preload the output of a fixed output derivation to the Nix store. Okay, so we're taking op flags and op args again. We have auto method, file ingestion method flat. Again, it would be nice to know what type this is. I mean, I guess this is the type, right? File ingestion method flat. Maybe that's fine. So we're going to detect flags. If the flag is the -- recursive method, we're going to change the method to file ingestion method recursive. Otherwise, we're going to throw an error unknown flag. Okay. And if arg is empty, we're going to have a usage error. First argument must be hash algorithm. And then we're going to parse hash types from the args, I guess the front of the args. And we'll pop the first arg because it's been consumed. And then we're going to do this thing again where we're going to iterate over the args and print to standard out in a way, I guess, that has side effects. Store.print store path. Okay. So that's kind of the flavor of this. Okay, here's a pretty long method. This is going to perform various sorts of queries. Yeah, okay. This seems like op query. All right, so we've got query type, default, outputs, requisites, references, referrers, closure, deriver, binding, hash, size, tree, graph, GraphML, resolve, or roots. All right. So we're going to check all these flags. And then we've got a bunch of else ifs. And then we've got a big switch statement, which is going to look at the various cases and then choose the appropriate action based on which case it's found. This looks hard to test, I guess, is my initial feeling. So let's see if we can find the tests for Nix store. So we do have tests. Will they load? There you go. Okay, so let's see. Lots of tests. That's good to see. See if we can find what is it? Nix dash store, Nix underscore store. And are we in a separate directory? Recursive REPL search. Y depends. Simple. So some of these are bash files. Some of these are, I think RB is Ruby files. Some of them are Nix files. I wonder, are there C++ tests? So CA certificate authority? I don't know. Nix shell.sh. So what are these shell scripts doing? This is just CDing and sourcing a REPL file. I don't know. Plugins, NixOS, lang config, common CA. Let's look at NixOS. Remote builds.nix containers. What does containers.nix do? So this is, I guess, the Nix language. It's going to set up some host stuff. And it's got a test script. Okay. And it's going to call like Nix build and check some results. All right. Are there tests in this file? In this folder, I mean, in the Nix/source folder? I don't know. What about Nix.store? Okay. All right, I'm not sure. So let's go back to see if the tests directory had a Nix.store folder. I think it didn't, but I was looking at files, so I want to give them a fair shake. Okay, so NixOS is the directory, maybe, and contain. Okay, I don't see them, but that doesn't mean that they don't exist. Okay, so that's Nix.store. Let's look at nixbuild.cc. We're going to import a bunch of stuff, including parse derivations, store API derivations, shell words. Recreate the effect of Perl shell words function, breaking up a string into arguments like a shell word, including escapes. Okay. All right. Main Nix build. We've got some flags, like is it a dry run? That's not passed in as an argument. Maybe it's computed somehow. And we've got run environment pure from args packages, auto delete, string args if heuristically to see if we're invoking as a shebang script. Namely, if we have at least one argument, it's the name of an executable file and it starts with the shebang. We've got struct myargs, legacy args, mix eval args. Okay. And we're going to do a bunch of flag parsing. I would kind of think that maybe the flag parsing should be either use a tried and true flag parsing library or essentially write your own. Because this, like all of this sort of stuff, I've written lots of code. I've written lots of code like this, especially when I had to like bang out a CLI, a command line program. But it's kind of, these things are kind of a nightmare to, first of all, it's a nightmare to understand as is, but they're also a nightmare to update and then go back and check that your command line arguments don't interfere with each other in non-obvious ways. All that sort of stuff is super hard. So I think it's totally normal to write code like this, but for something as complicated as Nix, I would kind of expect them to eventually try to go back and do the flag parsing in a more, I guess, more stable way. All right, so auto args and Nix shell, you run it. So we're doing a bunch of stuff like args shell. Like, what are we doing? And that's kind of what this function is up to. I mean, it's doing real work for sure. So we've got expressions, some sort of container, and we're pushing back a state, parse expression from file, resolve expression path. Okay. Yeah. Let's see. Here's auto build paths. We've got a standard vector of derived paths. And it says, note, we do this even when bang print missing to efficiently fetch binary cache data. We've got download size, nar size, store path will build, will substitute unknown, store query missing, will build, will substitute unknown, blah, blah, blah. All right. Yeah, so there's another like pretty big function that's got a lot of so these functions I'm seeing. Okay, so Nix, the programming language is is a functional language, and I haven't really looked at it. They say it's declarative, so I don't know if it's trying to err on the side of purity, like the way that Haskell does, where it's not about side effects, but at least what I'm seeing in the CC files is that they're really side effect heavily. There's a lot of like void functions that do a lot of stuff, and they're just kind of like chained together. And some of them are look like they're peeking at shell scripts and executing code and stuff like that. Nix channel. Okay, we've got another void function, read channels. We're going to check if a path exists. If not, we'll return. Tokenized string. We'll do a regex search for whatever this regex is. Let's see. It begins with, is that a literal S or is that white space? I don't remember. Star and then a hash. Is that a comment? Split, tokenized string. So if we get this, it kind of looks like it might be a comment. We're going to continue. Otherwise, we're going to tokenize the string and do some stuff. Okay, write channels. Write's the list of channels. I don't know what auto close FD is. I assume auto close means it closes itself. FD, I don't know. But we're going to open channels list.c string with some read write stuff maybe. If we don't get that, we're going to say that we can't open the channels list for writing. And we're going to write full. I'm not sure what full means, but maybe that means we like flush afterwards. We can add a channel and we do more. We're going to do some regex verification of the channel. And then I guess there's a format to the channel identifier, which we're going to check by this second regex. And if that succeeds, we'll read channels and do some stuff, assign the name to the URL, then write channels. Okay. Remove channels is going to do something similar. It's again void. Update. Update will fetch Nix expressions and binary cache URLs from the subscribed channels. Okay. All right. Build paths with result to JSON. Derived path to, so where am I? I'm at build.cc. Did we already, I don't think we looked at this. So we've got some JSON stuff, build paths with result to JSON. Does that save it to JSON? Let's see, where are we actually using? So auto J, T to JSON store. What is T? I don't know, but it seems like it's converting the store to JSON somehow. Struct command build, installables command, mix dry run, mix JSON, mix profile. Outlink, no link, print out paths. This is some sort of command pattern, maybe? I don't know. And then eval. So what is eval going to do? Command eval is got this stuff. It starts out by assuming it's not raw. We've got an optional apply, a path to write to, and we're going to add flag raw, print strings without quote. Is this the, I don't know if this is building the Nix language perhaps. So maybe, maybe if I look for Nix eval, where are the arguments? Apply JSON raw read only. So apply raw. Do we have write to? Write dash to? Write to. Yeah. So I think this is building the Nix language maybe, is what's going on in these files. And okay, that's kind of cool. And so how do you make a Nix command? We've got the struct command, and I think that's maybe the last file I was actually looking at. Is that right? Build? No, maybe not. Maybe this is just the build command. Command build. Okay. So this is command eval, and so I guess each command probably has its own file like this. Here's nar, command nar. Oh, so this is for the command nar. So I'm guessing source/nix is mainly about commands. Is that right? Add to store copy. So let's just pick one of these. Flake. So we've got markdown files, but are there corresponding CC files? Let's look at Flake. Yeah, I see. So let's look at Nix Flake URL. Is that not a thing? Okay, so we do get Flake URL. We've got some examples. Options, no-build, debugger, impure. Let's see if we can find these. Impure. What do we have? Let's see. The Flake command's got, we were expecting Flake URL. We're going to remove some flags that don't make sense. Maybe these are like default flags. And the only thing we're adding is template. Oh, that's Flake init common. Okay. Yeah, I don't know. Flake archive, add flag to. Okay, so this is defining a bunch of Flake commands. I think that's, and then here, this is perhaps, this markdown is the stuff that shows up in the manual, I'm guessing is what's going on. Okay, so so these are the commands for the archive. And then let's see. Can we find out where it actually builds stuff? Are the implementations in the or maybe they're in the lib directories? Common eval args, installable derived path, legacy REPL. And then in libmain we have common args, loggers, progress bar, shared, stack. And then what are the common args? Okay, quiet, verbose, option, max jobs, log format. Okay, so there are common args. And then what is in libstore? We've got a daemon. We've got derivations, derived path, file transfer, garbage collection, globals, local store, lock, machines. Yeah. Okay. So I'll take a look at some of these, and then I'll head out. Okay. Daemon.cc. First of all, how big is this file? Okay. So this is a pretty big file, which I was kind of expecting. Tunnel sync start work in queue message. A tunnel logger. It's a logger that forwards log messages to the client if we are in a state where the protocol allows it. Okay, so we've got a sync, which is kind of like, looks like a logger sync. We've got a tunnel source. We've got client settings, like keep going, keep failed, try fallback, verbosity. And a big switch statement with WOP. I don't know what WOP is. WOP is valid. Okay, I don't know what WOP is. I guess I'm not really going to dig further right now. Add temp root, find root, set options. Okay, so this is a huge function. I'm not sure how you would test this. It seems like you would probably want to break out each case into its own testable function so that you can write unit tests. We've got process connection, which again is void. Okay. And then derivations.cc. We've got derivation output path. Derivation CA fixed path. Derivation type is CA. Content addressed. Okay, so normally we do full standard visit to make sure we have exhaustively handled all variants. But so long as there's a variant called content addressed, it must be the only one for which CA is true for this to make sense. What is standard visit? Applies the visitor viz callable that can be called with any combination of types from variants to the variants var. These overloads participate in overload resolution only if every type standard remove reference. Okay, so this is something about reference, I think. Okay. Write derivation, valid path, parse strings. Okay, parse derivation. And then here we have local store. Are we importing anything especially interesting? We've got path locks, worker protocol derivations, nar info references, callback, SQLite 3, some schema migrations. All right. So local. So this, I guess by store, it means like a SQLite database. And these are just, these look like database functions. Registered deriv output. Okay, I wonder if, do we get the full SQL queries? All right, create table realizations 2. We've got primary key ID, deriv path, output name, output path, signatures, foreign key. Okay, that looks like a database to me. Lock, auto close FD. Auto user lock. We've got a UID. I guess this is UID and GID maybe from the operating system. We're going to acquire, use user namespace, NRDs, require experimental feature, auto allocate UIDs. We're going to create directories. Okay. Acquire user lock, use build users. Use build users. All right, machines. What does machines do? So we've got system types, SSH key, max job, speed factor, supported features, mandatory features, SSH public host key. And then we've got this thing for backward compatibility. If the URI is schemeless, is not a path, and is not one of the special store connection words, prepend SSH ://. So we're going to check if stuff is supported, check mandatory machine open store. If it has prefix SSH, we're going to store some stuff about connections. If it has prefix SSH or SSH next generation, we're going to do some stuff with keys. And we're going to call nix open store at the end. So is that in this file? We have machine open store. I think that's what we just looked at. Okay, we've got some base 64 stuff, parse builder lines, get machines. All right. nar info, HH, there's not a lot in the nar info HH. All right, narinfo.cc. We're going to take a store. We're going to take a string that's just called S. We're going to take a string whence, which I assume is from where the thing came. Valid path of store path dummy, hash dummy. Fix me hack. All right. Let's see. We're going to do some. We're going to check if it's corrupt. Parse hash field, have path false, have nar hash false. We're going to do this while loop. While I don't know why this is not a for loop. So we're going to set this counter basically to 0. And while it's less than the size, we're going to do some stuff. And we've got another big thing of if statements. This seems like it might be able to do a switch statement here. I don't know if there's an advantage to the if statements. And we've got this string, toString. And then references. We can search, which again is a void function. But what's it going to do with the search result? If not match, continue, standard ref. Okay, so we're going to set a counter. If set match to true. We're going to iterate over like this ref length stuff and check if it's base 32. And if something happens, we're going to say match is false and break. If not match, we're going to continue. And if match, then we're going to say standard string ref of s substring I ref length. What is s here? It's got a string view. String set. Are these like out parameters? If hashes erase ref, debug, scene insert, ref. Okay, so found reference to 1 at offset 2, ref I, and then we're going to insert scene insert ref. So scene is being passed in as a parameter that's being updated, I guess is what's going on. We've got the ref scan sync operator. We're going to pass in data. It's possible that a reference spans the previous and current fragment. So search in the concatenation of the tail of the previous fragment and the start of the current fragment. Okay. Rewriting sync operator, hash modulo sync, and hash modulo sync finish. Hash the positions of the self-references. This ensures that a nar with self-references and a nar with some of the self-references already zeroed out do not produce a hash collision. Fix me proof. Okay, so maybe they're unsure whether this algorithm is correct. I'm not sure if that's what proof means. So, okay, so libutil has some tests in it. Does libmain also have tests? No. Okay. So how many tests does libutil have? A few, quite a bit. Okay. We've got a LRU cache. Are they writing their own LRU cache? Seems like it. Cool. And then in libutil, we've got abstract setting to JSON, ANSI color, archive, args, callback. Are they implementing their own callback function? I'm wondering if this is for Nix, like a Nix callback, or if they're implementing a C++ callback. A callback is a wrapper around a lambda that accepts a valid of type T or an exception. We abuse standard feature T to pass the value for the exception. So callback, we've got a standard function, blah, blah, blah. Okay, so let's see if Nix has callbacks. Language basics. Let's try more aggressively using our search terms. Okay, I'm not sure. Let's try Google. Okay, so unclear. Maybe this is just their own C++ callback as opposed to a Nix, as opposed to a callback in the Nix language. I'm not sure. Closure. Compression, config, error, experimental features, format, get, LRU cache, ref.hh split. Oh, here's ref.hh. So what, let's see, ref. We've got memory, exceptions, and standard except. A simple non-nullable reference counted pointer. Okay, it is reference counting. Actually, wraparound standard shared pointer that prevents null constructions. All right. A simple least recently used cache, not thread safe. Okay. And then closure. Compute closure. Is this graph closure? Let's see. We've got get edges async. That's going to have a type T. And it's got a function, void, promise. So it's essentially a future. So it's going to, I guess, asynchronously get its edges. And then compute closure is a template that's going to have start elements, res, which is maybe result, and get edges async. And it's got a state of pending, res, and exception pointer. Children, yes, this seems like graph closure. Okay, so that was a quick look. Like I said, this would be shorter. I'm gonna also try streaming on YouTube. Maybe I'll do that tomorrow or Wednesday, just to see what the differences are like between YouTube and Twitch. So that's Nix. I didn't have the time. I think that it would really take to get a sense of, how they've designed everything. But at least I have a sense of where the code that does which part is, and also how they've, what the coding style is, and that really helps orient you to if you find something that's not working on your machine or whatever. That kind of helps. Having taken a look at it before, I find really helps you figure out what a good entry point is for solving whatever problem you have, or if you want to contribute to Nix. It helps, I think, to have a sense of where the code is, how it's laid out, and how things work at a fairly high level. All right, so that's it for me. Have a good one.